times the bore. This means pi by 4 into d square into L. That is the volume part, correct? यहाँ पे मैंने volumetric efficiency consider करने के लिए नहीं बोला. We are assuming 100%. Fine.
Yes, sir.
So no clearance, no nothing. But here pi by 4 into d square into L, out of this L by d is 1.2. So you will get something as 1.2 into d cube, correct? D square into 1.2 d. So that will be 1.2 into d cube, pi by 4 into 1.2 into d cube. So this is how you are asked to calculate the dimensions of the cylinder. So you finally you will get the diameter, and then you know the interrelation between the diameter and the stroke, that is 1.2 times. So you can find out the L. Okay, so as we proceed, I will tell you. Such type of numericals you had not solved.
Yes, sir. Such type we have solved.
Solved, na?
Yes, sir.
Fluid mechanics.
No, in IC engines here, sir.
IC engines. Okay, means any of the courses. It's fine. Now the table further increase. Vade. Temperature, pressure, enthalpy liquid vapor, entropy liquid vapor, specific volume liquid vapor, and specific heat also liquid vapor. Cp of vapor and Cp of liquid, naturally different. Okay, related to two temperatures or two pressures, whatever given. Fine, so let us start. The condenser temperature 35, evaporator -10, then nothing specifically mentioned, so we will assume the standard cycle. So x1 equal to 1 and h3 is as same as hf3. Correct? So h1 is hg1. So what is hg this? 1488. Oh, sorry, 1450. So over here 1450 and hf3. So this liquid 366. So the 366. Correct?
Yes, sir.
Fine. Now we plot the diagram. But over here, it is shown that 5 degrees subcooling. So instead of 308, it would be 305. So I have to calculate the enthalpy at this point, which is as same as H4. I cannot take directly as this value, as the HF3. I know HF3 value. From that, there will be the reduction further for the 5 degrees Celsius. And delta 5 degrees Celsius is as same as 5 Kelvin. No problem. Correct? So I will calculate this. H at 3 dash is the same as H4 because this is isenthalpic process. But that is not same as H3. So that is H3, basically HF3 minus Cp times delta T. And delta T is 5. Cp of the liquid given to you. Correct? So you substitute over there. Yes. Cp of the liquid given to you. So you substitute over there. Fine. Is this calculation correct?
Sir, why did we get minus Cp?
Minus Cp nahi. This is minus, means H minus C delta T, Cp delta T. You are reducing in terms of temperature, na? 308 to 303. So you are reducing it from 308.
Okay.
Cp delta T is to be reduced from 308 wala. Then what you get is at 303. This is not minus Cp.
Yeah, okay.
So this is my HF3. That means 308 minus Cp delta T times whatever is the product. So what you get is at 303. That is a subcooled enthalpy. At 308, enthalpy is 366. After subcooling, it comes to 343. That is why it is reduced. Subtracted. Clear?
Yes.
So you got only this H3 dash. That is what is important. Correct? H1 pata hai. Ab bacha H2. So again the same logic. S1 equal to S2. S1 is SG1 and S2 is superheated part. So Cp ln T2. Now everything is known to me. S1 is SG1. So minus ka SG. This 5.755. I substitute over here the same thing. Right? Then the other this 35, 5.2086. Correct? So that I substitute over here. Then CP. CP कहाँ से लिया? CP of water vapor part. So here specific heat vapor 2.903. Correct? So that is what is taken over here. And ln of T sup, which I don't know, by T sat. Now this T sat is the 308. I don't know this temperature. This is the saturation temperature. So I get the T2 value. Is this calculation correct?
Yes, sir.
Okay. ये part आपको पता है because you have covered it in thermodynamics. I only have taught you. Unfortunately, you cannot deny. Compressor का part पता नहीं. Okay, I can consider that. Okay, so this is my T2. So the saturation temperature 308, after superheating it comes to 371. And now once you know T2, you can calculate H2. So this is H2 dash, that is saturated, plus Cp times delta T. यहाँ पे minus किया है. Why? Because it is subcooled. Here it is superheated. So plus Cp delta T. So please cross check this calculation.
Sir, while subcooling, so the process will be a constant pressure process, right? So
Constant pressure process, yes.
so because we have already stopped at 3, which is already saturated liquid, and then we are subcooling. So we will be exiting the dome,
Yes.
right?
Yes.
So I thought you have drawn it on the.
Here.
So we have exited the dome, right?
Yes.
Okay.
It is slightly outside, left side.
Okay.
1 minute. एवढं कशाला काढलं कॉपी? हे एकच द्यायची असते. खूपच कॉपी काढले तुम्ही. तर मला एक चांगलं पेन द्या. Is the calculation correct?
Yes, sir.
H2. Fine. Now, mass of the refrigerant. You know 50 kilowatt capacity, correct? All the enthalpy values known. Correct? H1, H4, everything calculated.
Yes.
You can calculate the mass flow rate. Is this correct?
Yes.
Fine. Now, compressor power. The same m dot and H2, H1 you have calculated. H1 is Hg1 only. H2, that is superheated part, you have calculated. So this is your compressor power. Is this calculation correct?
Yes, sir.
Now, cylinder dimensions. So this is your mass flow rate, okay, which is equal to volume, means total volume divided by volumetric flow rate, specific volume. This will give you as meter cube. Then RPM, of course, that doesn't matter as such. And this is meter cube per kg, specific volume. So yeah, RPM ko, if you convert it as RPS, that is why divided by 60, because this is time factor. This is volume, meter cube. This would be meter cube per second, let's say, divided by meter cube per kg. So what you get is kg per second. And that mass flow rate, you know. Do you agree?
Yes, sir.
So this is how you calculate this. So you get the diameter and multiply by that factor given, whatever, 1.2 times. So that will give you length. Please cross check.
Yes, sir, if we had efficiency here, we would have divided it yeah,
Denominator.
yes, right? No?
In the
Denominator,
denominator, yes. Because this is theoretical one.
Hmm.
Practically, it would be even more. So
Yes,
divide by.
Yeah.
If it is a turbine, it is multiplied by. If it is a compressor, it is divided by. Is the calculation correct?
Yes, sir.
Okay. So any problem to anyone? No problem?
No, sir, no problem.
Good. Now just a minute. हे एक याला स्टेपल करायचं एक याला स्टेपल करायचं आणि इथे एचओडी सरांची साईन इथे एचओडी सरांची साईन आणि नंतर मग आपल्याला परचेस म्हणजे स्टोर्स मध्ये जायचं ते मी नंतर सांगतो. ओके. Now we move to the pH diagram part. So I have shown you about the variation in the type of examples I can set for the theoretical part. That means thermodynamic equations. Now we will shift entire thing into pH chart. So this is the first example. Please open that ASHRAE handbook yesterday, which I had shared with you. A refrigerant 2L, that means R2L. So open the chart for R2L. Open the file. On the first page itself, there are the short links provided. So click on R2L. It will take you to that particular chart. First, you will have the table. After that, there will be chart. Are you getting it? Green color table and then chart on the very next page. Are you getting it?
Yes, sir.
Fine. So let us read now this example. R12 vapor compression system operating at a condenser temperature of 40 degrees Celsius and evaporator temperature of -5. So here the temperatures are given, pressure not given. So what we will try to find out the temperature line corresponding to 40 degrees Celsius and -5 degrees Celsius. Now if you observe the chart on the left hand side, the temperature lines are vertical. And once it passes inside the dome, it becomes horizontal, obviously, because it is a phase change process. Correct? So we will try to find out the intersection of the saturated liquid curve and the temperature line. I will show you that. Okay, develops 15 tons of refrigeration. So here the TR capacity is known. Using the pH chart of R12, determine the following. So determine the following बाद में. First of all, we have to complete the cycle. उसके बाद ही सब calculation. So nothing mentioned over here for the superheated part or the subcooling or nothing like that. Correct? So we will assume for the standard cycle, that means state 1 at the saturated vapor and state 3 at the saturated liquid. Okay. Now you come to the chart. Are you getting this chart R12?
Yes, sir.
Now the temperature lines corresponding to 40 degrees are something like this, vertical. So we will find out the intersection of this saturated liquid curve and 40, like here. Are you getting it?
Yes.
Yes, sir.
Similarly, the other temperature given is -5. Okay, so this is 0 intersection. This is -20 intersection. So what you should do is इसका एक vertical line लेने का, that is 0 degree. इसका एक vertical line लेने का, that is -20. Measure the distance between them. Okay, let's say 1 centimeter. Then split it in 4 parts. Why? Because -5 na 1/4. And it cuts somewhere, let's say 1/4 part. It cuts somewhere over here. You draw that horizontal line. That is your -5 line. Do you get it? Or any problem? Should I repeat it?
No, sir. What?
Okay.
So please repeat it once again.
What do you want? What do you want? Is 40 clear or -5? What is the problem? If you tell me the problem, then only I can repeat. No?
So the 40 part.
40, what is the problem? This is 40. See, you have to tell me the problem at least. What is the point of otherwise repetition? It will be same and you will be again facing the same problem. What you have
Oh,
not
so I
understood?
was saying R22. Sorry, sir.
Huh?
I was saying R22, not R12. I
Wow,
think.
wow, wow.
Sorry, sir. Got it, sir. Got it.
So 40 you can directly locate. What remains is -5. So as I told, 0 ka ek vertical line le lo, 20 ka vertical line le lo. Measure the horizontal distance that is equivalent to this 20 degrees delta. What you want is 5 degree. That means 1/4. So let's say if this is 1 centimeter distance. So make it as 0.25. Means 2.5 mm. So 2.5 mm from here, 0 degree to the left. Draw it vertically wherever it cuts. That is your -5. And draw the horizontal line. So that completes about your evaporator temperature line. Any difficulty still?
No, sir.
Atharva, is there any drawing software over here? Or maybe paint?
The Jamboard.
No, I don't have that. Let's try it through paint only.
So it's there in the classroom only.
Classroom?
The meet only.
No, I don't know how to use it. Wait. Where is the paint part?
You can click on more options. You'll see a whiteboard.
But then how to draw?
Normal, sir, with your mouse, just like paint.
Okay. I got it over here also. Let me share it. This new technique we will try at some other time. Otherwise it would be wastage. Can you see this? Paint.
Yes, sir.
Now your saturated liquid line is, I will draw it in some larger scale. Something like this. Okay, curve. Saturated liquid. Do you agree?
Yes, yes.
Now your 0 degree vertical line, -20 vertical line. Correct? You measure the distance in between them. Then this is 0, this is -20. What we want is -5. So that means 1/4 of this. Let's say over here. Do you agree?
Yes, sir.
Now take this wherever it cuts the saturation line. This horizontal line is corresponding to -5. This is how you can complete the cycle. Here you have already got the 40 degrees. Here -5. Are you clear?
Yes, sir.
Anyone having any problem? I used to draw this in the classroom itself, no, on the blackboard. Now I don't have that much facility available, but I'm trying my best to do it the other way. So this, I repeat, this is 0 degree, this is -20. Draw the vertical lines, measure the distance, make it 1/4 to make it corresponding to -5. Draw it again vertically downward wherever it cuts. The saturated liquid line, draw the horizontal line. That is your -5 degree isotherm. Fine. And this is how you complete 2 lines up to this part. Okay. Any doubt?
No, sir, no
Fine.
doubt.
Now what you do, H3 is equal to H4. We are assuming this as HF3, saturated liquid. So you can draw a vertical line directly. Now the only part missing is this. So इसको क्या करना है? Let's say this is your saturated vapor. Correct? This is the dome. Saturated liquid and this is saturated vapor. So it goes like this. It is written over here, saturated vapor. Okay. So you find the intersection. That is your point 1. Now again, I have to draw through what you call this, paint. Up to this. Fine. You got this point 1?
Yes, sir.
Huh? Okay. Now again, I will go back to the paint part. Is this visible?
Yes, sir.
Okay. Now I will enlarge this part. And let's say something like this. Okay. Saturated vapor. Now your location, your 2 pressure lines are same. Why pressure would change? Temperature may change, but pressure would not change. So I will draw a horizontal line, something like this. Condenser. Another horizontal line for evaporator. Fine.
Yes, sir.
Now here is your point 1. Correct?
Yes, sir.
Now you want to draw a isentropic line, compression line. So what we have, let's say I will show some enlarged view. One isentropic line like this, and the other isentropic line is having naturally different slope, something like this. Okay. This is whatever isentropic line given on the chart, one line and the second line. Your point is falling in between. Are you getting this on your chart, page chart?
Yes,
Yes,
sir.
sir.
One line on the left hand side, other line on the right hand side. Correct? Now how to draw a isentropic line? Because iska slope alag, iska slope alag. So what you should do is a technique. Rahul, बसून घ्या, मी लेक्चर झाल्याशिवाय आता करणार नाही. So what you should do is you measure this particular total distance and find out the fraction for this. Let's say 40%. Okay. Then you measure the total distance this. Okay. Take its 40%. And then join the line from here to here. Are you getting it clear now?
Yes, sir.
Because you cannot draw a line either parallel to, like neither parallel to this nor to this. Correct?
Yes, sir.
So you need to measure the distance between 2 isentropic lines, find out the fraction on the lower temperatures or lower pressure, that means evaporator. Same procedure you have to repeat for the condenser part, higher pressure, find out the same fraction, this intersection, and then join this. That will be the exact technical procedure. Now coming to our part. So this is my HG, or rather let's say HG, vapor part, correct, over here. Then it is falling between these 2 isotherms. Isentropic, sorry, not isotherms. Isentropic lines, correct? So find out the distance at this particular pressure between the two, find out the distance between this particular pressure between the two, find out the ratio here, and join. So here comes into picture the accuracy, how accurately you draw the line. So complete the chart, read these values and cross check what I have got as H1, then H2 and H3, H4. Are you getting it closer? Let me know. Rahul? Yeah. काय करायचं आपल्याला? चेंज करून पाहिजे. हो, हे आपला किलोमीटर दुसऱ्या खंडमध्ये बरोबर आहे. ठीक, म्हणजे लागणारच. हे असं नाही पाहिजे, स्टेपल पाहिजे. स्टेपलर आहे. बस दुसरं लेटर ठीक, ह्याला होऊन जाईल. नको, दोन्ही एकदमच घ्या. ते ऑफिसमध्ये स्टेपलर आहे की टाचण्यापेक्षा लावायचं नाही, हरवलं की गेलं काय, सरळ स्टेपल करायचं. आर यू गेटिंग द व्हॅल्यूज? H1, H2, H3, H4. Cross check.
Yes, sir.
Fine.
Yes.
So here it is a graphical part. Naturally, there is a permissible error. It may be plus minus 5 or something. So you are allowed to get 345 and 355 for H1. Or for H2, 380 and 370. That much permissible error is allowed. If you write for 350 instead of 375, then not allowed. Okay, so let us decide for your MST or ESC, permissible deviation is plus minus 5 kJ per kg. I'm not saying 5%. Because 300 ka 5% will be 15. And that is a very serious error. Only plus minus 5. Fine. Should I move ahead? Everyone has to get it. Till that point, I will wait because that is my responsibility. If someone is having the problem, please discuss.
So sir, basically we'll have to carry a printout, something like that.
Print out of what?
Of this document.
Yes, the chart. That's why I shared the entire ASHRI chart, na?
Yes,
ASHRI book with you, na? So whatever is the type of refrigerant I say, R11, R12, R22, R134A, R717, whatever it is. You have to just open that, draw it, and read the values. Okay?
Yes, sir.
अमितकडे घेऊन जायचं. आणि ते जसं काढलंय दुसऱ्याचा तुम्ही फोटो काढला होता त्याचा ओरिजिनल तिथे आहे, त्याच्यात 2 झेरॉक्स घेऊन कशाला तो अमित दिल ना काढून तिथे. ओके, आर यू गेटिंग इट?
Yes, sir.
So hopefully all the students are getting this value H1, H2 and H3 equal to H4. Maybe in a permissible error of plus minus 5. As I had said, H1 can be 355, H1 can be 345. Anyone, any single person in the class not able to trace, then let me know. I will repeat it. Everyone got it?
Yes, sir.
Fine. So now your job is done. All enthalpy directly got. No thermodynamic formula required. Correct? Nothing to remember, nothing as such to any chance to commit any mistake, plus, minus, nothing. Just plot on the graph, read the enthalpy value, see how people have taken care of your efforts. Hemant Khush.
सर गेट में नहीं देते सर ये चार्ट.
I know. गेट में नहीं देते, इसके लिए आपको थर्मोडायनेमिक फॉर्मूला का भी न्यूमेरिकल सॉल्व करके दिया है.
Yes.
Fine. So both methods you can use. I will specify the method to be used in your MST or ESC. If I tell you to solve without chart, then thermodynamic formula. If I supply the chart, then you have to show me the cycle which you can plot on the chart. Okay, even though your answer may be correct, but if the method is not something which I may tell, then absolutely 0 marks. Because if I ask you to solve using the chart, and if you solve by thermodynamic formula, that is not what is expected from you. Okay, so you have to be, what I can say, having the mastery on both the approaches. Reading the chart also accurately, and remembering all the thermodynamic formula also. Fine, should I go ahead?
Yes, sir.
Okay, so what is the refrigeration effect? H1 minus H4. What is mass flow rate? That is 15 TR capacity known. I converted into minute per minute. You can use for per second, per hour, whatever it is. So I used 211. Do not take 210 in general Indian author books. So 15 TR into conversion factor divided by the refrigeration effect per unit mass, that is per kg. So you will get the mass flow rate. Is 3.157, you will get kg per second. Or use 12,660, you will get kg per hour. Fine, theoretical piston displacement. So you know the mass or other mass flow rate and V1. Now how you will read V1 from the chart? Here, this gives me the density kg per meter cube, correct? 10. What is the reciprocal of density? Specific volume. So you read the density at state 1, correct? This is 10, this is 15, 20, 30, 40, like that. So here it is around 15. So density is 15 kg per meter cube, reciprocal of that is meter cube per kg. And that is what you are going to substitute over here. So you get the theoretical piston displacement. Then the next part asks is piston displacement per TR. Now you know TR, that is 15 directly given. So this is meter cube per minute per TR. Next part is power consumption. That is the compressor work. So H2 minus H1, mass flow rate is also known. So you can directly get in terms of kilowatt. Correct? Then power consumption per ton divided by 15. And the heat rejected is condenser. So that is H2 minus H3. Mass flow rate already calculated. This is how you solve by using the chart. Any doubt to anyone in the entire class? Till the last person gets it clear. That is my job. That is my responsibility to wait and make him understand. So even one person would be having any problem, please let me know. Yes, any problem to anyone?
No, sir.
Very good. Okay, then Carnot COP. Carnot COP is related to temperatures. So condenser temperature and evaporator temperature, both you know. So you calculate the Carnot COP. 40 and -5, correct? And actual COP, which you calculate with the help of the enthalpy values. Done. So this is how you solve the numerical. Should I move ahead?
Yes, sir.
Yes, sir.
Okay, good. A simple Freon 12 refrigerator, same F12 chart or R12 chart operates. पहले जमाने में उसको फ्रियॉन बोलते थे, इसके लिए F12 बोलते हैं. Now we call it as refrigerant 12, so we call R12. They're one and the same. Okay. In the old books you may find F12. In the latest books you will find R12. Fine. Simple F12 refrigerator operates between the temperature limits of 15 and 50 degrees Celsius. Can you plot the lines now? Can you find the lines?
Yes, sir.
Huh. The heat required to be pumped means what? Is 100 megajoule per hour. What is this? Heat required to be pumped means what? Evaporator, absorbed, or condenser? Rejected.
This is a
It
condenser.
rejected it.
It rejected.
Why?
Sir, this is the same cycle, but it may be a heat pump, I think.
Heat required to be pumped दिया है. Pumped means taken. Absorbed. Or is it rejected?
It is rejected. It's a heat pump, sir.
Otherwise, heat required to be absorbed. ऐसा
Yes.
लिखा होता.
Yes, sir. Heat to be taken away or something like that.
What is the meaning of pump? Pump is from take from some particular location and deliver at some particular location.
सर इट इज कहीं पे तो सर इतना एनर्जी पंप करना है, उसका ऐसा मतलब है सर. तो अभी स्टोरेज स्पेस में इतना एनर्जी हमें पंप करना है और उसको कुछ एक टेम्परेचर पे मेंटेन करना है.
I agree. So what it should be? Pump
This-
means what? Let's say water pump. What do you mean? Water is to be pumped from, let's say, lower location to higher location. So is it like the discharge part or the suction part? Now, unfortunately, or rather fortunately, water is an incompressible part. Pump work is very, very small over there. But what for the gases? Would it be larger, or rather it will be larger? So is it a suction related part or the delivery related part? It's a gaseous compressor. Determine whatever is asked. That is okay. That is not a different difficult task. What is the interpretation of the first line? That first means second line.
Sir, it's the amount of heat to be taken away from the system, right?
So evaporator. Taken
No,
away
sir,
means
it has
evaporator.
to be condensers, sir, pump.
How many are there saying condenser and how many are there saying evaporator?
Sir, evaporator.
Condenser, sir.
Condenser.
Let's see. Try to plot it and check the values. काय झालं? नको असू दे, त्याने काय फरक पडतो? फोल्डर मध्ये. बरं आत कोण आहे? बर मग फोल्डर नाहीये तिकडे. बरं आम्ही कुठे गेला? ऑफिसला गेला असणार. मी सकाळी आलेला आहे. नको ते आणण्यात जाऊ दे, थांबा जरा. लेक्चर संपलं की बघू. तुम्ही जेवून घ्या. लेक्चर संपायला वेळेत जेवून घ्या. नंतरचा वेळ वाया नाही घालवायचा. So here you get exactly the half of the distance, correct? This is 60, this is 50. What you want, 40. What you want is 50. So half of the distance. Draw vertical line 60, draw vertical line 40. Half of that distance, that is your 50 directly. Do you agree? Yes or no?
Yes, sir.
Yes.
Yes, sir.
And over here, draw vertical line for 20, draw vertical line for 100. What you want is 15. So 1/4 of that particular total length from 20 side. And draw the vertical line wherever it cuts, draw the horizontal line. That is your 15 degrees Celsius line. Then find out the intersection. Find out if it is falling on any of the isentropic lines directly, then you are fortunate. If not, then the same ratio. And here you draw simply vertical line. That is done. Job is done.
Yes, sir. Values are matching. But how did you get the S2 saturated? So
What is so difficult in that? S2 saturated means the intersection of the
yes, sir.
saturated curve. Huh?
Yes, sir. So
Entropy
initially
lines
it
are
was
known.
1.55. It was lying on the line itself.
These are the entropy lines.
Yes, sir.
Huh?
So
Correct.
you have just subtracted some
No,
part.
why? Why do I need to subtract? I get this value, let's say. This saturation
Yes, sir.
curve.
Yes, sir.
Correct. So here. So it is falling between two isentropic lines.
Yes, sir.
This is 1.75, this is 1.7. Let's say my point is somewhere here. So I can find it out. Same
Basically
logic,
linear
taking the ratio.
interpolation. Right?
Huh?
Okay.
Taking the ratio, interpolation.
Okay.
If you want even accurate value, you can refer to the table. Actually, chart and actually table. I found it by linear interpolation.
Okay, sir.
Then 1.5 and 1.55 के बीच में. Do the linear interpolation, find out 535. Okay, enthalpy values matching.
Yes, sir.
Yes, sir. Fine. So should I move ahead? Anyone wants any further discussion? Should I move ahead?
Yes, sir.
Fine. Now in the numerical, dryness fraction enter in the evaporator. Matlab state 4, correct? Entry to the evaporator. Exit to the evaporator is compressor, that is dry saturated. Entry to the evaporator, that means your 0.4 here. So what is the value? These all lines are related to the dryness fraction. You can read 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. All those are dryness fraction. So your point falling over here, and this line is related to 0.3. So, and this is 0.2. So again, linear interpolation. So how much value are you getting? लेक्चर चालू आहे. हा काही पण. How much you are getting?
Somewhere around 0.25.
0.25. My value is 0.26. If your enthalpy values 4 and 1 are correct, and the F value, HF, it would be slightly here and there deviation, naturally, because graphical error. Fine. Okay. What next task is mass flow rate of the refrigerant. How would you find out? Now this comes into picture. Mass flow rate is refrigeration effect divided, means total, divided by the specific one. So here it is given 100 into 10 raised to 300 megajoule. Correct? This is pumped. I had given that hint. Pumped means what? To take from lower part and deliver it at the higher part. So pump means suction. So that is a refrigeration effect, not the condenser, evaporator. Do you agree?
Okay, sir.
Okay, heat required to be pumped. Pump means lower se utha ke upper pe delivery. So how much is to be lifted from the lower section? That is important. You add the compressor work, that is delivery. Who said first law? That is okay. Total energy. Or rather, sorry, second law. But what I'm interested in is how much is to be pumped, how much is to be lifted. So that is why 2. That is basically refrigeration effect. And divided by the specific refrigeration effect, H1 minus H4, that is per kg. So you get kg per hour converted to kg per minute, kg per second, whatever you want. Is the calculation correct?
Yes, sir.
Now the second part asked, third part asked, discharge temperature, that means T2, assuming the specific heat of the vapor as 0.8. So that means they want us to use the thermodynamic equation. So S1 equal to S2, right? S1 is known, SG1, and S2 is superheated. Now out of that, this saturated part we have taken from the chart or maybe from the table. Cp is given to me, and that is must because Cp is not mentioned in the chart, and ln of T soup by T sat. So T soup superheated, I can calculate. Is the calculation correct?
Yes, sir.
Now you can cross check the same value from the chart also. Here, this particular temperature line is your 50 degrees Celsius. it starts falling down from here, correct? This line, can you see this? This is corresponding to 40 degrees. Can you see? This 40 line is like this, ending over here. This 60 degrees Celsius, this line is ending over here. इसके बीच में 50 है, which is over here. Now your line is slightly shifted on the right hand side. Correct? तो इसकी line चाहिए. So you draw the line, graphical line. So it would be falling like this. Correct? Do you agree?
Yes, sir.
So इसका intersection ले लो. Superheated part है ये. तो इसका intersection ले लो. Saturated. It will be somewhat above this. 50 degree के थोड़ा सा ऊपर. Correct? Something like this. On that saturated vapor line, you take the intersection. So somewhere on the upper side, then draw the line over here and find out the intersection. That should also give you the same answer. Do you agree? So you can find out graphically also. You can find out by using the thermodynamic equation also. Are you clear with the procedure? Or should I
Yes,
draw it on paint again?
Sir, it is clear.
Clear to everyone, or should I draw it on paint? Those were not clear. Because this is required in other numericals also. I think better to draw it on paint. What I can do, let's say, then your line is, or your state is somewhere over here. इसको भी उल्टा कर देते हैं. Your state is somewhere over here, let's say. Okay. Now your temperature line, this value would be somewhat like this, falling. Second temperature line may be somewhat falling like this. Same logic, linear interpolation. Correct? So iska temperature line would be somewhere here, let's say. Correct? This is your state 2. So let's say this is your temperature line. And let me complete this on this side. So this is another temperature. So you complete your temperature line as the horizontal one up to this part. And this is your standard value. Graph area, this is standard value. You find out this as the linear interpolation. The procedure which we had adopted on the liquid side is to be repeated in a reverse way for the vapor side. यहाँ से उल्टा जाके. Earlier what we have done is liquid side, and then we trace this line and reach up to vapor. Now I want you to do it in the reverse way. So you find out this temperature. कैसे करोगे? So you draw that line, you read it over here, liquid side, and then see how much fraction it is. So let's say this is 40, this is 60. Let it come at whatever, let's say 1/3. So 20 degrees ka 1/3. 7 degrees, let's say. So 40 plus 7, it will give you 47 degrees Celsius. Are you getting it?
Yes, sir, got it.
Fine. So this is how you got the temperature. Now the piston displacement, m dot you have calculated, and specific volume. Specific volume is 1 upon density. You can read the density. So that part is done. Correct? Then power consumption, which is related to H2, H1, compressor part. Enthalpy value is known. Mass flow you have calculated. So that will give you the power consumption. And the actual COP, that is our same formula. Refrigeration effect H1 minus H4 divided by compressor work H2 minus H1. Fine. Any doubt?
No, sir.
Good. So I think we should stop over here. At least now you have got the idea about how to deal with this thing. So on Friday, no, not Friday. Why to waste a Friday? Thursday only. Thursday our regular session जो भी है उसमें I will engage for the lab part, because now you have got all the pressures, correct? Condenser pressure, evaporator pressure, 3 batches. So try to plot it now. R12 के चार्ट पे इसको प्लॉट करो. You know the pressures directly, and we will try to find out the COP. Experimental COP already calculated, correct? Yesterday. The theoretical COP we will try to find out. Is that fine? Tomorrow you have holiday, so relatively free, no lectures. CR, when is the Friday session? What time?
Friday there is no session, sir.
No, not Friday, Thursday, sorry. Regular session.
12:20.
Thursday, 12:20. Okay.
Yep.
So at that time we will meet for the lab part, not theory. I will not teach anything, only for the lab discussion. So that we can plot the cycles, all 3 batches, and compare the results. Okay. So I hope now you have got some kind of confidence, at least, how to use the pH chart. Of course, I will be there for your lab also. I'm not saying you to plot everything and just directly give me the results, final results. I have to cross check. But at least you have some idea how to plot it. So here we deal with the temperature line. In the lab, fortunately, the pressure directly given. Fine. Should I end the meet? Any doubt to anyone?
Sir.